Hello, everyone. It's Mr. Blevins here, and today we're going to go over Chapter 10, Section 1, which has to do with exponents. Okay, so just for reference, in the Big Ideas Math 8 book, this chapter or this section starts on page 384. So if you wanted to follow along with the notes, also follow along with the examples once I go over those, that's the page that we'll be on here today, or that we're starting on here today. So to start off this section, we need to learn some different terms. So there are actually 3 different terms we're going to learn in this section. They may be things that you have seen before, but we're going to cover them again anyways, just because exponents are a very important part of what we're going to be doing the rest of the year. So in order to be able to understand and do the things that we need to do later on in the year, you are going to have to know how to use and evaluate exponents. So first definition that we're gonna talk about today is the definition of power. Okay, so a power is what we're gonna call a product of repeated factors. Okay, so with this definition, there are a couple of other words here that you need to know about, but I'm hoping at this point you have probably seen before. But if not, let me just go over these really quickly with you. So once again, this is the definition of power. But we see this word product here, okay? And from before, hopefully one of your previous teachers, when you've maybe seen this word, has told you about how this word actually has a relationship to multiplication. So when we are talking about a product, okay, we are talking about multiplying things together, okay? The next word here, I just want to mention just briefly here, is the word repeated. So when we say something's repeated, it happens over and over and over again. And then we've got the last term here, or the last word in this definition, which is factors, okay? Now, factors, when we talk about factors in math, we are talking about things that are multiplied together. So when we talk about factors, we are actually talking about numbers. Okay. And since we are getting into talking more and more about algebra, um, we're talking about numbers and variables. Okay. We talk about variables here because variables do represent numbers, and variables can be factors as well. Okay, so whenever you see that word factors, we're talking about numbers and variables here. So if we look at this definition again, we have a product, so we're multiplying a bunch of different numbers and a bunch of numbers and variables together. But in this case, it's going to be a repeated number or variable. So it's going to be the same number and variable over and over and over again. Okay, so the other 2 definitions here to go over really quickly are base. Okay, so when we talk about a base in terms of exponents, the base is the factor. Okay, so factor meaning the number or the variable that is repeated. Okay. And then lastly, what the whole section is about here, let's talk about what an exponent is. Well, the exponent, in relation to the 2 previous definitions, the exponent is just how many times . How many times. 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 the base is repeated. Okay, now if you're still unsure what we're talking about here in terms of power, base, and exponent, let's actually look at an example here of a power so we can understand what the base and exponent of a power are. So let's take the one they have in the book there, -3 to the fourth power. So starting off here, -3 to the fourth power, this whole thing is what we call the power. It's, once again, a factor, which in this case is going to be the -3. So that's what we're actually going to call the base here in just a second. And an exponent. So that's what the exponent is here, is the 4. So like I said, the whole thing here is the power. So looking at this again, just as I hinted at just a second ago, the -3, that's what we're calling the base. And if the -3 is the base, that means the 4 has to be the exponent. Okay, so when looking at a power, the base is always the bigger number that is on the bottom, okay? And the exponent is always the smaller number that's above the bigger number, okay? So we talk about things repeating up here, but you don't really see anything repeating when you look at -3 to the 4. But what -3 to the fourth power actually represents is, this is -3 times -3 times -3 times -3. Okay, so now you see where we get this idea of repeating. When you have an exponent, it tells you how many times you repeat the base. So in this case, since the base is -3 and the exponent is 4, we have -3 times itself a total of 4 times. So it repeats itself 4 times. And I do want to point out this is multiplication, okay, product. It is a multiplication. So when we go through here, we can simplify this by just going through and doing order of operations. -3 times -3, that's a +9. We still have the negative times -3 times -3. Now we do 9 times -3, which is -27. And if you like to, I always, in general, just put my negative numbers in parentheses so I don't get anything mixed up with subtraction. Okay, it's always a good habit to have. And then lastly, we have -27 times -3, which gives us a +81. Now we'll get more into this in terms of evaluating powers in actually example number 2. But as of right now, this is what we mean by a power is a product of repeated factors. It is a product, meaning these are all multiplication, okay, of repeated factors. So we have a factor of -3, and it's repeated 4 times. Okay. So one thing I do want to point out here is notice the parentheses around the -3. Okay. Always make sure to use parentheses around negative bases. Okay. Like I said, it is good, especially when we get on into some of the more algebra things in terms of solving equations and solving inequalities and graphing equations and inequalities. Putting your negative numbers in parentheses does not hurt a thing. It actually helps you and keeps it to where you know this is a -3, not that this is -3 or so that it kind of keeps you from making that mistake and thinking that this is subtraction when in fact this whole thing is a number. It's -3. Okay, so once again, use parentheses when you have negative bases. And like I said, in general, when you have a negative number, it's always good to use parentheses just to make sure you understand and can separate your negatives from your minus signs. So if you look at page 384, we're going to start with example 1 here, and then work our way through the another couple of examples here. So if you wanted to follow along in the book, that's what page we're going to be starting on here. So let's look at example 1. Okay, so example 1, they tell you this has to do with writing expressions using exponents. Okay. So what we're going to be doing here is we're going to be given a product. Okay. So as the instructions will say here, the instructions say write each product using exponents. Okay. So we're going to write each product using exponents. So let's look at part A. With part A, we have negative 12 times, so that's what that little dot there means, negative 12 times negative 12 times negative 12 times negative 12. Okay. So notice from the previous video there, if you watched it, this is a power. Okay, we can represent this as a power because this is a product. Okay, so product meaning multiplication of repeated factors. So we need to ask ourselves two different questions here. Okay, we need to ask ourselves first, what number is being repeated here? Okay, another way to ask that question is, what is the base? Okay, what is the repeated factor that we're dealing with here? And in this case, the repeated number or the repeated factor is actually negative 12. So we start off with writing the number or variable, as we'll see in the next example, that is repeating. Okay. Notice it is a negative 12, so I am using parentheses, just like I mentioned in the last video. It's always good practice that if you have a negative number, okay, especially if it's a negative base of an exponent, to always use parentheses, okay? And we'll see why that's important in example 2. But like I said, always use parentheses. And like I said, it's good practice to use parentheses when you're dealing with pretty much any negative number, okay? But we know that the base is negative 12, okay? Once again, that's the factor that's repeating. And now what we've got to do is we need to count how many times the negative 12 or the base repeats. So as you see here, we've got 1, 2, 3, 4, 5. So since we have 5 negative 12s, that means our exponent is going to be 5. Okay, so just so we're clear about that, the base is negative 12 and the exponent is 5. Once again, that's because negative 12 is the number that repeats, and it repeats 5 times. So it's there 1, 2, 3, 4, 5 times. Okay. And that's really all there is to it when you're writing expressions using exponents. Okay. But let's look at part B here, and we have an interesting development with this one. So in this case, we've got a product that is called A times A times A times A. But it doesn't stop there. We also have times B times B. Okay. So this one's kind of unique here in that we actually don't have only one base. We're actually going to have 2 bases in this case. Okay, so let's draw our attention to the very first of this. Okay, so once again, if you remember from the last video, um, the base is whatever factor that's repeated. And since we're talking about factors, they can be variables too. Okay, so we have the variable a here. So our first base is going to be a. Okay, so once again, first base is a because it is a factor that is repeated. So in this case, we're not even looking at the b's yet. Since we know this is a base, how many times does the a repeat? Well, we have 1, 2, 3, 4 a's. So that means the exponent on a should be 4. Okay, now that we've taken care of the a's, let's look at the other factor. The other factor we have over here is b. Okay, so that tells us the base for this part is b. And how many times is it represented here? Well, there's 1, 2 b's, so the exponent on the b is 2. Okay, and then that's really all there is to it. Now, if you feel more comfortable, you can add the little dot in here, okay, to represent multiplication. But just in general, if you do have two variables right next to each other, even if they have exponents, it is understood that this operation right here is multiplication. So you have a to the fourth power times b to the second power. Okay, and much like up here, let's label our bases. So in this case, we have two bases. We have a and we have b. And then our exponents, so we have two of them here since we have two bases. Our exponents are 4 and 2. Okay, and once again, that just comes from seeing what's repeating. So in this case, what's repeating is a. It's being multiplied times itself 4 different times, so it's represented here 4 times. So the exponent is 4. And then we have another base over here, so another factor that's repeated, which is b. So that means it's represented 2 times, which means exponent of 2. Okay. Now, I do want to point out, if you notice underneath this example, there is a few questions that are on your own. Okay. I'm going to ask you guys, if you want a little extra practice, to do those questions. And what I plan on doing is providing you with those answers as I push out the video, so that way you can keep track and make sure you're doing these correctly before you try any of the practice assignment or the homework assignment. Okay, so I'm going to put a little note down here. Try the on your own questions, and they will give you a little extra practice there. And once again, I'll provide you with those answers along with the video and the notes that will accompany those, so that way you can check your answers there. So we are going to skip those in terms of what's going to be going on in these videos. So just for future reference, like I said, we'll go through examples, and if there are any on your own questions, they are going to be. I am going to ask you to do them on your own, and like I said, I'll provide you with the answer so you can check your own work. Okay. But let's go ahead and go to example 2. Now, example 2 is actually a very important example. Okay, so if you remember from earlier, I was talking about using parentheses when you have a negative base. And this example actually shows you why that is important. So this example has to do with evaluating expressions. Okay. And the instruction is pretty straightforward here. Evaluate each expression. Now, one thing I do want to point out here, when you see this word evaluate, okay, and a little key word inside the word here, this is a compound word, and if you look right in the middle of that word, you see the letters V-A-L-U, okay? And what that means is you're going to be looking for a value, okay? So in this case, when you're asked to evaluate anything, you're actually looking for a number. So in this case, we need to find what this is equal to. So we actually need to go through the process of doing all the operations and getting a number at the end, okay? So let me just show you what I mean here. So let's look at part A. In this case, we've got -4 to the 4th power. So how you would evaluate, okay, an exponent like this or a power like this is you would write it. So we would do basically the reverse of what we just did in the last example. We would take the exponent and we would write it out. So in this case, the base we see is -4. Once again, the parentheses are going to be important here because, like I said, when we look at the second part, you'll see exactly why they're important. But in this case, this tells us the base is -4, and it's going to be repeated 4 times. So we're going to have -4 times -4 times -4 times -4. Okay, so let's go ahead and go through here and simplify this. So that means actually going through what we call the order of operations. Okay, in this case, the only operation is multiplication, so this is pretty easy, pretty straightforward. We'll talk more about order of operations actually in the next example because there are other operations in those. But in this case, we just go through like we did at the very beginning of the note video. We see that the first thing we have here is -4 times -4. If we do -4 times -4, that is +16. We still have the times -4 times -4 here. Okay. So let's simplify the next part. 16 times -4. That's actually going to be a positive times a negative. This is going to be a -64. Now, once again, where this is going to be negative, it does not hurt you to put that in parentheses because, like I said, later on when we're doing more complex things, you really don't want to mistake this negative sign in front of the 64 as a minus sign or a subtraction sign, okay? So where it's a -64, let's put parentheses around it, and we still have the times -4 over here. And then the last step, we would have -64 times -4, okay? So since we have a negative times a negative, this is going to be a positive 256, okay? Now notice here, this ended up being positive, okay? And that's going to be the key here because when we go over and look at part B, you'll notice something different when we write this out. Okay, so part B has the same numbers here, so we have -4 to the 4th power, but you'll notice the parentheses are missing. Okay, so let me separate these with a line here so we don't get them mixed up. You notice there's no parentheses with this expression. Okay, so this is where, once again, the parentheses are important because since we do not have parentheses here, that now tells us, well, we have this negative out here. So let's go ahead and write this negative, okay, because it's out here kind of by itself. But now we see that the 4 that's here is actually only being raised to this 4, not the -4, okay? So in this case, this exponent is only beside this 4, okay? So that means, so unlike over here, you can see the exponents being raised to what's in the parentheses. Well, what's in the parentheses is -4. Here, the 4 is only, this exponent is only being raised to the 4, not the negative as well. So what we end up having here is we have a negative out front by itself, and our base is actually positive 4. So we end up with 4 times 4 times 4 times 4. Now notice what happens when we do this. Well, negative stays out front. 4 times 4, 16. We still have times 4 times 4. The negative still out front. 16 times 4. Well, from over here, we know that it should be 64 because we have a positive times a positive, so it should be a positive 64. We have a negative here. 64 times 4 is 256. Okay? But here's where we have the difference. Since we have this negative out front and it's not part of the base, once again, the exponent is always directly next to the base. Okay? So in this case, the exponent of 4 is only being raised to this 4. That's where we get this part. That means the negative is out front by itself, but then we go down here and look. Well, we have a negative of a positive 256. Well, what's the opposite or the negative of a positive 256? Well, that is a negative 256. So, as you can see, what happens here is if we do not have the parentheses around our base, okay, it actually makes a big difference here. It's a difference between having a positive 256 and a negative 256, okay? And this is exactly why it's important to use parentheses. So if you do know your base is negative, okay, put parentheses around it. If you do end up with something like this, okay, and there's no parentheses around the negative 4, then that means the exponent is only being raised to what it's directly next to. Once again, notice here the 4 is directly next to the parentheses. Okay, and since it's directly next to the parentheses, it's directly next to everything that's in the parentheses. Here, there's no parentheses, so this exponent is only being raised, is only modifying or being used by the number that's directly next to it, which is the 4. Okay, so once again, that's the big deal with parentheses. Okay. So knowing if you have parentheses or not, that's how much it can change things when you are talking about exponents. Okay. So let's go ahead and look at example 3. Okay. And this will be the last example that we'll go over in this section. We are going to skip example 4. Okay. But if you look at example 3, this one has to do with using order of operations. Okay, so I told you in the last example, order of operations would be making an appearance, and here it is. Okay, so when we are talking about order of operations, just to refresh everybody's memory, we are talking about PEMDAS. Okay, you might know it as PEMDAS, or you might have seen it as GEMDAS. Okay, or you might know it from the expression. So once again, one of your previous teachers might have told you this, but if you go through, you can actually make a sentence out of this, out of an acronym, and it says, "Please excuse my dear Aunt Sally." Okay, so you might remember it from knowing that little funny saying there. Please excuse my dear Aunt Sally. Okay. Any way that you need to remember it, order of operations works the same no matter which way that you think about it, okay? Parentheses, exponents, multiplication, division, addition, and subtraction. But I do want to point out, when you are dealing with the multiplication and division, I usually like to put parentheses around those, because those tend to happen, and you'll see as we talk about these examples, those happen at the same time. Okay, so what I mean by that is if you have both multiplication and division in the same expression, you do whichever comes first from left to right. Okay, so even if division comes first, you have to do division before multiplication. Okay, and the same thing goes when you're talking about addition and subtraction. So you'll see me write it. Whenever I write it with parentheses around addition and subtraction because it works the same way. If you have both addition and subtraction that needs to be done, and subtraction in terms of coming from left to right, if subtraction comes before addition, you got to do the subtraction before you do the addition. Okay. Once again, hopefully your previous teachers have mentioned something about that to you. Okay. I'm going to kind of assume from here on out that you know that that's what's going on here. So if you do not understand what I'm talking about here, you've definitely got to let me know because order of operations is something we're going to see over and over and over and over again this year. Okay. And you'll see it a lot in algebra and you'll see it a lot in geometry as well. Okay. So make sure you know the order of operations. And one little hint for you is if you struggle remembering the order of operations, get in the habit of writing PEMDAS or GEMDAS at the top of your paper whenever you're working on anything. So that way you always have it there for you. Okay. But with that being said, let's actually jump right into the example and look at the instructions. So the instructions, much like the last one, the last example, we are going to evaluate. Okay. Once again, evaluate, we're looking for a number, so we're looking for a value here. Okay. So evaluate each expression. So same instruction so far, but notice here it asks us to do it. So just evaluate each expression when x is equal to 2. Okay, so this is a little bit different than the last example in that we're going to have expressions that have the variable x in it, and we're told that x is going to be equal to 2. So let's look and see what we actually have to do here. So let's look at part A. In this case, we have the expression 7 plus 3 times x to the second power, or x to the fifth power, excuse me. X to the fifth power. Okay. So the first step whenever you do this is first I would write down the expression. So when you're working this out on your own paper, and I do highly suggest that you write these down when you're going over these, especially when you're doing the homework and the practice work. Make sure you write this stuff down because if you don't write it down, some of these questions, there's no way you're going to be able to do all the calculations you need to in your head. So you got to take it step by step. So first step, write down the expression. And now we're going to rewrite the expression. So notice I'm rewriting it exactly as it is, except I'm going to change one thing. For every x that I see in my expression, I'm going to replace it with a 2. Now notice here I did put parentheses around my 2. That's just a habit that I have. And once again, it's probably not a bad habit for you to pick up in that if you do substitute anything in for a variable, it's usually good to put parentheses around it because you know now that you substituted in the number 2 for the x. Okay, so whatever's in the parentheses, that's what you substituted in there for x. Okay, and now after we do that, it is just straight order of operations. Okay, so we go through. Do we have any parentheses or grouping symbols? Well, yeah, we have parentheses here, but the only thing in the parentheses is the number 2. We can't simplify that any further, so we go on to the next thing. Are there any exponents? Okay, that's what the E in PEMDAS means, or the E in the order of operations. That's exponents. Well, yeah, we have an exponent right here. So we're not doing anything with the 7. We're not doing anything with the 3. But we have to do the 2 to the fifth power first. Okay. Well, what is 2 to the fifth power? Well, once again, if you need to, you can go off to the side, or there will be a calculator that is provided to you with the assignment that you'll be completing. So if you need to, you can plug in 2 to the fifth or multiply 2 times itself 5 times. But when you do that, okay, so once again, you can verify this on your own if you need to. But like I said, you would just evaluate this the same way we just did in example 2. You would take the base. So let me just do it with this one so you can see what we're doing. You would take the base and you would do 2 times 2 times 2 times 2 times 2. Okay, and then we do the exact same way. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, 32. So 2 to the 5th is actually 32. And like I said, if you need to go off to the side and multiply this out every time, that's fine. If you'd rather use a calculator to double check and make sure that what you get here is 32, I'm fine with that as well. Okay. Just as long as you know how to deal with powers and you know what you're doing when you have 2 to the 5th. Okay. Now, we go through order of operations again. Now our new expression, do we have any parentheses now? Well, no. Do we have any exponents now? No. Do we have any multiplication? Well, yes, we do. We have 3 times 32. So before we do the 7 plus 3, we've got to do 3 times 32. Okay, so we're not doing anything with the 7, but we are doing 3 times 32. And once again, if you need to, you can go over here and do 32 times 3. 3 times 2 is 6. 3 times 3 is 9. So in this case, that is 96. And like I said, if you need to come over to the side and do that calculation, that's fine. Or if you'd rather check yourself on a calculator, same kind of thing. If you do 3 times 32, you can verify that that is 96. And then the last step here, there's only one operation, but let's go through it again. There's no parentheses, no exponents, no multiplication or division now, but we do have addition or subtraction. So we do have addition. So that's the last thing we've got to do. And 7 plus 96 is 103 or 103. And like I said, if you needed to, you could go off to the side and add that out, or like I said, double check yourself on a calculator. But that's really all you have to do. Is if you're given an expression and it's got a variable in it and they tell you what that variable is, you just plug it in and do order of operation. So last part here, let's have a look at example 3, part B. Okay, so part B, and just to remind everybody, we've got x is equal to 2. Okay, but with part B, we've got a little bit more difficult of an expression. We have 5 to the 4th power minus 27 x to the 3rd power, and then we have that divided by 3. So once again, first step should be writing out your expression. So just like I've done here, write out your expression. And then before we do any calculations at all, so before we do the 5 to the 4th, before we divide anything by 3, before we multiply anything times 27, we need to replace this x with a 2. So I'm going to rewrite this entire expression again, replacing the x with 2. And once again, notice I'm using parentheses here to indicate, hey, I put in a 2 where this x was. Okay. Once again, it's kind of the same thing with using the parentheses with a negative number. When you plug something into an expression, it's always good to use parentheses because, as in this case, if we just put the 2 in here and then raised it to the 3rd power, it would look like we had maybe 272 here when actually it's 27 times 2 to the 3rd power. Okay. So once again, use your parentheses. Okay. My opinion, there's no such thing as too many parentheses. As long as you can tell what operations you need to be doing, that's the main thing that matters. Okay. So if you need to add parentheses in here to make it known that this is 2 to the 3rd power and not 272 to the 3rd power or 27 times 2 to the 3rd power or anything like that, it's 2 being raised to the 3rd power. So same kind of thing here. like I said, if you need to, we can write PEMDAS or GEMDAS at the top of our page. So we have something to go on. And like I said, I usually like to write it with the parentheses around the M and the D and the A and the S. Just so, like I said, I know there's something special about the multiplication and division and addition and subtraction. But in this case, we go through. Are there any parentheses? Well, the way I've written this, yes, but the same thing as the last example, or last part, was it's just a number 2. So we can't do anything with that, so we go to the next thing. Do we have any exponents? Well, yes, we actually have 2 sets of exponents. So this is where order of operations kicks in again. Since we have 2 of something, we work from left to right. So the first thing we've got to do is do the 5 to the 4th power. And like I said, if you need to, you can go off to the side. That's 5 multiplied times itself 4 times. So 5 times 5 times 5 times 5. I'm going to hold off on doing that right now because, like I said, for sake of ease here, if you need to do that, you can. If you'd rather, like I said, use your calculator to double check this, 5 to the 4th power is 625. Okay. But once again, notice what I'm doing with the rest of this. I'm writing it exactly the same as what it was before. Okay. So we go through order of operations again. Are there any parentheses? Well, yes. Are there any exponents? Well, yeah, we still have this other exponent we've got to do. So everything else is going to stay the same. We're not doing anything with the 27. Once again, the exponent only refers to what it's directly next to. So it's only going to what's in the parentheses here, which is the 2. So this is 2 to the 3rd power. I'll put a little dot here to represent that this is multiplication. Well, what is 2 to the 3rd power? Well, once again, you can go off to the side and do 2 times 2 times 2. There's many of you that are probably going to be tempted to say this is 6. But just to show you, 2 times 2 times 2, 2 times 2 is 4. 4 times 2 is 8. So 2 to the 3rd power is actually 8. Okay. And then we still have the division by 3. So to continue on with order of operations, any parentheses? No. Any exponents? No. Any multiplication or division? Well, yes, we have multiplication and division. So now we work from left to right. So we're not doing anything with the 625, but we are going to do 27 times 8. So we have 625 minus 27 times 8. And once again, if you need to, double check this on your calculator or go off to the side and actually multiply this out. But 27 times 8 is 216. And we still have the division by 3. And once again, every single step you notice I'm going through order of operation in its entirety. So now, are there any parentheses? No. Any exponents? No. Any multiplication or division? Yes. We have division here. So once again, we're not doing anything with the 625. But now, and the minus is still there, but now we've got to do 216 divided by 3. Well, once again, you can go over here and do the long division. 216 divided by 3. I'll go ahead and tell you that is 72. And then lastly, there's only one operation, but let's go through order of operations just to make sure. No parentheses, no exponents, no multiplication or division now, but we do have addition or subtraction. Mainly, we do have subtraction. So 625 minus 72 gives us 553. Okay, once again, you can go off to the side and do that, or I'm going to stop saying that now. So hopefully everybody's got the point on this. So if you need to double check yourself on a calculator or need to go off to the side and do that calculation, that's perfectly fine. I'm not going to clutter up the example here with all those different calculations because, like I said, that's something if you wanted to check on your calculator, you can. So I do want to point out, like I said, notice how many. This was a pretty big expression, but it only took me 6 lines to complete this, and that's with me going through order of operation and only changing one thing in every step. Once again, 5 to the fourth, 2 to the third, 27 times 8, 26 divided by 3, 625 minus 72. Okay, so that's a good practice to have. When you're doing the practice and the homework assignments, make sure that you are following order of operations. And if you need to come back to this video to see how I did this and understand how I did this example, this example works the exact same way as the questions on the homework and the practice assignments. Okay. Now, I did want to remind everybody about the on your own questions. As you'll see after example 3, there's another couple on your own questions, or another, I guess it's 4 on your own questions. Once again, do those on your own if you want extra practice. And like I said, I will give you the answers to those so you can check your work. Okay. As I said earlier, we're going to skip example 4. There's a variety of different reasons. But just know that we're skipping example 4 for right now. So all you have to be responsible for is what happened in examples 1, 2, and 3. Okay. So like I said, refer back to this video if you need any extra help when you're doing your practice or your homework. And like I said, every single question on the practice and homework works like exactly like the questions we've done in the example.